Oh, and we're back again after this short video break. So before I introduce our next speaker, I want to point out to the Global AI Cafe that you can join to meet people and chat with them and also chat with our previous speaker. And I want to remind you of the Cloud Skills Challenge, which you can take in the next 48 hours and where you can win lots of prizes like Microsoft certification vouchers. So without any further ado, our next speaker, Malte Rijman. Hi, Malte.
Hey,
Hey, how are you going? How are you doing?
I'm doing great. How about you?
I'm doing great as well. You're going to talk about AI as easy as creating a PowerPoint.
Yeah.
That sounds really cool. But before you start, can you introduce yourself a bit?
Yes, so I'm Malte. I'm studying computer science for my bachelor's degree, and I'm also part of the Microsoft Learn Student Ambassador community.
Sounds great. And you're going to talk about AI and creating PowerPoint with it, right?
No, not quite. And
Oh,
you
I'm
you
sorry.
will see in a second, but the title is more about the as easy.
As easy. Okay, then the floor is yours. And let us see what your session is about. Good luck.
Thank you. So I'm gonna share my screen. Here we go. So you've already learned a little bit about me. I've brought some more questions, so you can learn some fun facts about me. First up, do I like to prepare food? Yes, I do like to cook for myself. However, regarding the second question, if I am a farmer, even though I've spent a month between graduating high school and starting university on a farm, I'm definitely a software engineer and not a farmer, so that's a nope. The next question is, do you work on project using AI? In the beginning of this year, I've started a small hobby project using AI, and you'll see a snippet of that in a second. Have I used Python for machine learning? Well, here it gets a bit complicated. In university and especially in math, I definitely learned a lot of concepts that are part of machine learning, like convolutions or Fourier transformations. However, up until this semester, I haven't been able to participate in any machine learning courses, but now I'm taking a course on cognitive systems, and there we've written some Python code in respect to machine learning. So how about you? I would like to post your emojis to the corresponding to the questions. So if you like to cook, post a heart in the chat. If you are a farmer, post the seed emoji. And if you work on project using AI, use the clap emoji. And lastly, if you use Python for machine learning, use the mind blown emoji. I'm curious to see at the end which kind of emojis you all posted in the chat. If I had to guess, my hunch is that regarding the first two questions, most people who have cooked before aren't necessarily farmer and have grown their own food. And regarding the second pack of question, which is related to this conference, my assumption is that most people who've worked with AI projects are also familiar with Python. This will be more important later, so keep that in mind. But before we get to the content, I want to highlight my goal of this talk.
Just a quick question. Can we use multiple emojis?
Yeah, of course.
Cool.
If you have yes to more than one answer, please use multiple emojis.
Nice.
My goal for this talk is to empower everyone to create machine learning solutions with least effort. And by everyone, I mean everyone. So if you haven't written a single line of code in your life, that's awesome, because to be honest, in this talk, we are also not going to write a single line of code. And hold on, if you're a machine learning expert, I encourage you to stay, because I think you will also get an interesting perspective. Now here's the application I started building in the beginning of the year. It is a basic food tracker, but instead of having to search the foods I want to track, I can simply point my camera at them, and then I only need to punch in the amount, and it will calculate all the nutritions for me. So how would I get started building such application? Well, one idea might be to use a pre-trained model that we might find on the internet. So here we have an example of that. However, as we can see, the leftmost image with the Chinese palace is corrected correctly. Nevertheless, the right image, which shows a flower, is labeled as a vase, which isn't quite what we wanted. So what would be another option? Well, we might write our own model. So here you can see an example of how this might look like. And currently it is training, and even though it is only training one epoch, so quite shortly, which is not optimal, we can see that once it is done, so we'll skip that and see how it runs through, that the accuracy is quite low at only around 40%. So this might not be an option for us to go forward for building our application. So I want to take a different approach. Instead of starting to cook out like a Michelin chef for a wedding, how about we start simple with some basic spaghettis? So for that, you can see I've already taken some pictures of food that we're going to use as our data, which you can see on the right-hand side. Now we already have some data, so let's see how we can use it. And for that, I'm going to demo you Lope AI. So let's have a quiet moment that the live demo gods are calm. Here you can see I have on my desktop Lope AI open. Lope is a project or an application by Microsoft to build machine learning models for image classification. So to start, let's create a new project. We'll give that project a name. And on the left-hand side, you can see the process in Lope consists of 3 steps. First, we need to upload some images as our data and label them. Second, we train a model. Well, not we, Lope is doing the heavy lifting here for us. And the third and last step is that we can use our model. So let's start with the first step of labeling some images. Here on the right-hand side, I can import images. Because I've already taken some, I will upload some from my computer. So let's select some of them Apple images you could see before. And once they are uploaded, we will see them here in the pane and we can label them. So for each image, we tell Lope what kind of class this image belongs to. Now that we've labeled all images, we can see them here and correct them, because I see I've made a small mistake here. We of course want the picture that looks like an apple to only be part of the apple class. Now, as some of you might know, computers, when we talk about image classification, we need at least 2 classes. So the computer can categorize an image in one of these 2 classes. So before we go further, we need to add a second set of images. that belongs to a different class. So for this, let's take some red bell pepper images, upload them as well, just like we did for the apple. And go ahead and give all of them the label we want to associate with this image, which is the red bell pepper. So immediately now that we have two classes, we can see here on the left-hand side that Loeb is starting to train with the little circle. So now it is great. It is a great time to take a small recap because we could sit back and relax. What did we do? We created our own data set by taking some pictures of food. Then we imported it into Loeb and labeled all the images according to the class which they belong to. Once the images are labeled, which is probably quite familiar in terms of a machine learning process, the training is all done by Loeb. So we just need to sit back and wait till the progress completes.
While we are waiting for that, I have a question, like, can we also export the model once it's trained to be used somewhere else?
A little bit patience, I'm going to come to that in a second.
Sorry for the spoilers alert.
That's fine. Maybe you could hear the nice chime sound, which is Loeb letting us know that it is done training. Yeah. And in fact, now that it has trained a model, we can move on to the third step, which is using our model. Here we have three options: either upload images, hold items in front of our camera to let Loeb predict what it sees, and later on export it. We'll come back to that in a second, but first let's try it out. So let's go to the browser, and well, we uploaded red apple, so maybe it would be interesting to try it out with a green apple. So let me go ahead and simply take some image. And save that. Okay, so now that we've downloaded some random image from the internet showing an apple, we can just drag it into Loeb. Here we go. And yay, it correctly identified the green apple as an apple, even though we only uploaded red apples. So we can let Loeb know that it did a good job by pressing this green check mark, and it will take the apple image and add it to our training set. That is great. However, in our kitchen, we often have different items as well. So what might we have also in our kitchen? Maybe a knife. And so I'll go ahead and search for the some image of a knife and take this one and save it. Okay, so now that we have some item that we also find in our kitchen, but that isn't a food item, we can take the image of the kitchen knife and drag it as well into Lobe. And sadly, we see this result isn't what we expected. We can clearly see that there's no red bell pepper in this picture. So we need to improve our model. And in Lobe, we can easily do so by, in this case, adding maybe a category of items that we have in the kitchen, but that we don't want to have in our nutrition app because they aren't food. And we can add them from this view screen directly into the training data set. So now you can see on the left-hand side here, we have the other category, which now contains the image of a knife, in addition to the apple and the bell pepper categories which we had before. This mechanism of trying out your model and then improving it is super effective if you want to iterate quickly and want to get to a first prototype. So let's wait once again a couple seconds till Lobe has trained with the new class taken into account. There we have this nice friendly chime again, and we can see the result isn't quite as good anymore, in the sense that we only have 68% which are correctly predicted. So the takeaway here is that because the other category has only one image in comparison to the other classes which have multiple images, this is why we get this kind of screwed result. So we would definitely need to add more images so that we have a balanced number of images in each class. However, if we are happy with this iteration process, we can even go ahead and optimize our model. Here, Lobe is going to train so long until it doesn't find any improvements anymore. I will not take you through this now, but you might try this out yourself. Now, let's say we are happy with our model. And here we come to the question of how do I export it? Well, the Lobe team has also thought that through. They have different options for you to upload the model to popular frameworks so it can be used. In addition, they even have example projects which can get you started. So if we take a look at this web project, we can see that we could basically go ahead and clone this GitHub repository, export our model for TensorFlow.js, and we would basically be off to the races. Now, building the application is out of scope of this session, because then it becomes a question of being a web developer or being able to create native applications. So with that, let's switch back to the slides. Now that we went through the demo, I have one slide for all the experts of you. So those who are just getting started with machine learning can sit back and recap the demo for a second. And for the expert who are interested, Lobe AI is based on popular machine learning algorithms, ResNet 50 and MobileNet V2. And it's quite interesting because ResNet 50 was also the one we used as the pre-trained model in the example in the beginning of the presentation. However, we could see that we could vastly improve the results using Lobe. In addition, for all the Python folks out here, Lobe also has a Python API that you can use. So for your experts, I highly recommend you, when you start your next machine learning project, to build a simple prototype using Lobe AI, and then apply all the knowledge you have once you know that the scenario you're planning to address makes sense. Now, back to everyone, not just the experts. If you are interested, what did we just see? Well, we basically built an end-to-end machine learning solution in about 10 minutes, having no knowledge about the underlying machine learning algorithms, and neither having any knowledge about the math behind them. However, I want to caution you. No matter what project, it is important for you to define what success means for you. So you know which tools and which solutions you should apply to solve your project. Start small and add complexity later as you go. Let's have a look at the key takeaway. Some people definitely have interest in farming, and they are important to our society. However, I think we can all agree that if we want to cook some delicious meal, we are not necessarily interested in growing our own foods. And it is a blessing that we have this abstraction in our society where we can simply go to the supermarket and buy food. And I think the same applies to machine learning. And this is the key takeaway. In my opinion, it is important that we have people who know the machine learning algorithms and do the math. However, for machine learning to scale and to build awesome solutions, we need to get everyone involved. And so tools like Lobe AI are perfect to do so. Now, what did we do in Lobe AI again? Well, we took some of our own pictures, or you could, of course, get some pictures from the internet as your data set. Then you import them and label them in Lobe, and Lobe will train a machine learning model for you. The last step is to improve iteratively your machine learning model until you are happy and you can export it and use it in your use case. Now, here's my call to action. If you are going to start your machine learning project or are going to start your next machine learning project, start with Lobe AI. Build a simple prototype. And then once you have the idea figured out, maybe if you don't know how to code, get allies involved who know how to code. Secondly, share what you're going to start by posting to Twitter using the Student AI Conf hashtag. If you do have trouble, feel free to reach out. On this slide, I have some resources for you to learn more about the information I talked about. And with that, I'm open for questions.
Wow, very cool tool, very great session. Personally, I never heard of Lobe AI before. Never, ever. And it looks really easy to upload and label images and create basic models out of it. Really cool. We have a couple of questions. First one, is Lobe only for image classification or also for any other AI tasks like text classification and so on?
The short answer is no. Currently, Lobe is only for image classification. However, I can expand on this a little bit. So you've already mentioned that you haven't heard of Lobe before. And this is quite easy to explain because Lobe only exists since last December, so it's quite new. I've learned of Lobe through a marketing email, which I have to be honest, convinced me because the email just looked as pretty as the UI you just saw. It is just a pleasure to working with Lobe, which is why I choose to use it for the food tracking app. And with that said, the Lobe app itself is still labeled as beta, even though I have to be honest, in my opinion, I've seen worse UIs and worse functioning products in production. So I don't think the beta label is convincing to me. However, I want to give a huge shout out to the Lobe team, because as I can see, or my assumption is that they are an awesome team, and there have been at least 3 updates already this year, so they're constantly improving, and based on their timeline, I think they're definitely thinking about adding more usage scenarios, like, for example, object classification as well, so you can classify objects within an image and not just label the entire image.
Yeah, and after your session and after seeing Lobe, I totally understand your title of this session. I totally understand it now. So I have another question. So what is the difference between Lobe and custom vision, another technology Microsoft has for image classification?
So to emphasize this, even though Lobe doesn't have the Microsoft branding directly, it is a Microsoft product. So it is also part of the ecosystem, if you want to say so. And regarding the differences, here it becomes interesting, and I think this might be a bit confusing, because on first look, both are definitely the same. Custom vision and Lobe can be applied to the same problems, no question. But there are 2 factors to keep in mind. In my opinion, it is all about having tools and options available. Not everyone works the best with, let's say, only custom vision, or if only Lobe existed. So I think it's totally viable that both exist, so you can find the tools that work best for you. And then the second point I want to make is that there is a stark difference in the sense that Lobe is first and foremost a desktop application. So you could use it completely offline, maybe if you don't have fast internet available to train your model. Whereas custom vision is a cloud solution, so you will be connected to the internet. That would be one difference to point out.
Yeah, correct. Yeah.
Thanks. So, yeah, I have a question for Malt. Yeah, so we're talking about talking about this like for beginners and all these things. You also mentioned a brief about like TensorFlow, right? So how would you compare Lobe with like some other alternatives like TensorFlow.js, which is also like offering similar stuff, which is like upload your data set, it will train the model, it can also export, and you can use it elsewhere. Yeah, that's one question. And the second one is, what would you tell us a bit more about like what is like the data management thing that happens in Lobe? Is it like gonna be can it like work on like the local system, or does it like the processing requires in like some cloud provider or something? Because as far as I know, like in other platforms like TensorFlow.js, everything happens in the user's browser as well. So if you could just shed some light on that, that'd be great.
Regarding the first question, in my opinion, TensorFlow.js has a different target demographic. So first and foremost, web developers. And second, I would, as far as I can tell, for using TensorFlow.js in your application later, you will still need to know some basic knowledge about the API and everything. And on Lobe AI, on the other hand, the target demographic is no matter what developer. So you can be a web developer, you can be a backend cloud developer, you can be a native iOS or Android developer. So this is one difference. And furthermore, Lobe is solely focused on the labeling and training process. And then, as you could see, the export options, one of the export options, for example, is TensorFlow.js. Others are regular TensorFlow. So there they overlap a little bit. Once you export it, you might move on to a different framework. Regarding the second question for management, Lobe is a completely local application. So you have you upload the image or you import the images. I think import is a better word in the sense that you don't upload anything to the internet. All the files remain locally. And then you could see the labeling screen is kind of your management tool. It is fairly basic in the sense that you only see the different classes of labels and the images associated with them. And there you could delete, add, modify them.
Cool. Yeah, thanks a lot for answering. That answers my question. Yeah.
Great.
Yeah, there are a couple of more questions, but we are a bit out of time right now. So maybe you can look in the chat to answer them, or the people who are asking can join the Global AI Cafe afterwards. So I really want to thank you for this session, and I'm really happy that I now know about Loop, and I'm definitely going to check it out. So thank you very much. And with that, I'm going to hand over to you again, Kunal, for the next speaker, right?